Hey, this is Roland McPherson. I've got a new R&R height of cut gauge here. It claims that it accurately measures height of cut to 1/1000th of an inch. And I believe that all of the height of cut gauge manufacturers make the same claim of accuracy. Let's check this thing out. I've got the latest edition of my height of cut gauge calibration plate here. I'm going to use this, and I've noticed that the indicator is not square. It's a little crooked this way. That's not really a big deal for this type of gauge, but it is noticeable. It looks to be, just looking at it by eye, it looks to be perpendicular to the bar. Let's see how flat it is. So I can check that without having to molest this gauge in any way. I don't have to take the catch off. I don't have to hang it over the side because I've got the hole in this calibration plate. I can just lay it on there like it is. And I'm going to take a 2000s feeler gauge, and I notice that I can slip it through here. And there's a couple other points that I can slip it through. But it's not bad. I've seen a lot worse. Okay, there's a little dip in the surface of the gauge there, but that's not bad. The thing about this calibration plate is it does not matter if this gauge is not flat. I just like to get a general idea of how flat it is. So if I were to cut away this section of this calibration plate, you would see this here. On this side, I've got a simulated height of cut of 0.205 with a simulated top face of 0 degrees. And on this side, this height of cut is also 0.205, but there's a 10-degree angle up this way. And in another video, I explain why I incorporated this 10-degree angle to this calibration plate. Okay, let's take a look at this again. This is an analog gauge, and I noticed that it is at 0 when it's at rest. I also noticed that the base plate here, or this base is protruding above the surface, the working surface of the gauge. All right, and the gauge is pretty flat, and I measured this collar. Sorry, it took me so long to think of the name. This collar is protruding above this flat surface by about 10 thousandths. I measured it. I got about 10. And if it's showing 0 when it's actually above the working surface, that's going to be a problem. So here's what it looks like. The this collar is above the surface about 10 thousandths. So let's measure this height of cut with a 0 degree top face first with this gauge. And I usually mark the location of where this gauge contacts the rollers, okay? And then I suspend it. I suspend the gauge above the calibration plate. And that, in this case, I'm using 20 thousandths shims. So the height of cut that I'm simulating is going to be 205 plus 20 is 0.225. And this, what this does is allows me to calibrate a gauge even if it's not flat. It could have a significant bow in it, and I could still calibrate it accurately using this method. Okay. So I almost forgot my handy dandy mirror here. So what do we got here? We've got 0.216. We should have 0.225, and we got 0.216. And I am sure that that is primarily due to that collar sticking up above the working surface of the gauge by probably 9 thousandths, because this is indicating that our height of cut of 0.225 is 0.216, 9 thousandths less than the actual height of cut. So if we use this gauge on a greensmower with a top face angle of 0 degrees, the actual height of cut would be 9 thousandths higher than what we would be setting the mower to. Okay, and I wanted to get that documented before I start calibrating this gauge, which I will go ahead and do now. So I'm going to move the dial so that we are indicating 0.225. Okay, now this gauge is calibrated to 0.225 for a top face angle of 0 degrees. Now it's not going to read 0 when it's at rest, but that doesn't really matter. What it reads at rest really means nothing. What's important is, what does it read when it's measuring a known height of cut? Let's flip it around and see what it reads with a simulated height of cut of 0.225 and a 10 degree top face angle. Let's see what we get here. We're getting 0.236, which is 11 thousandths higher than our actual height of cut. That would be bad, because if you set your greensmower to 100 with this gauge, and your top face angle was angled down 10 degrees, your actual height to cut would be about 11 thousandths lower than what this is indicating. Okay, so I wanted to get that on record, and I'm sure that that problem is because the bottom of this catch is not tapered, it's flat. So what's happening is this flat catch bottom is measuring from somewhere behind the shear point to the bottom, or the surface of the feeler gauges, which is simulating the ground. Okay, so just to recap, this gauge is calibrated now for a top face angle of 0. It's indicating correctly 0.225 or 0.226. That's pretty close. Okay, but it is giving us the wrong indication for a 10-degree top face angle. Now there's a solution to that, and that is to replace this catch. And I'm going to do that, but while I'm replacing that and tinkering with this, I'm going to see if I can eliminate this collar protrusion and get it down. And I'm going to see if I can, with a reasonable amount of effort, move this indicator so that when this is at rest, it will read 0, and it will accurately measure both heights of cut. So stay tuned for that. I'll do another video of that.